All right, before I throw two new methods at you, let's review the first two from Friday. One method from Friday. 12, only one. 12, one method I showed you how to prove triangles congruent on Friday. Number 12. There's two. Look back if we need to. There's two methods I showed you how to prove triangles congruent that involve S's and A's.
Side angle side.
Side angle side. And the other method I showed you on Friday to prove triangles congruent. 3. Side, side, side. Yep. All right, real quickly, what was so important about side angle side? What did I need to know about that angle? I wrote it in that place for a reason. 13?
The angles in between the two sides.
Correct. Angles in between the two sides. I asked that question because here is way number 3 to prove triangles congruent. ASA is acceptable. What do you think that stands for? Angle side angle, and in particular, look where the S is. So if you're going to use angle side angle, where's the darn side? In between the two angles. Yes, correct. In between the two angles. It's got to be in between the two angles. Angle side and angle side angle. Everyone see angle side angle here. Now, do you remember on Friday, I said, all right, if the angle is not in between, there's no other method, right? We should not be writing down that or the opposite version, right? No such thing. Well, for angle side angle, if the side is not in between, it's still okay. All right, if I don't have angle side angle, but the side is somewhere else, that's still okay because now I have my fourth way, which is angle angle side. All right, that is going to be used if that angle is not in between. It can still be congruent. And you guys see the difference. Notice how the sides in my diagram here are not in between versus angle side angle, they are in between. All right, so bottom line, ready? Bottom line, if I have two angles and a side, you're good. If I have two angles and a side, you're good. You just got to figure out, is the side in between or not? All right, you ready? Actually, you know what? I think I'm going to have you guys do this one as a group, and then the next one we'll do together. All right, because I think the next one's a little bit tougher. So go ahead, take a look at this. What I suggest, mark your diagram. Have a plan before you write down step 2. What is the method I'm going to show before I start writing things down? Okay, so you and your group right now, go ahead, write down the givens, mark your diagram, but before you write down statement and reason 2, you better have a plan and a way to show those triangles congruent, and then write it. So I'll give you guys 3-4 minutes here to talk. Have a plan. How are these two triangles going to be congruent? And then go ahead and write down everything you need. Hold on. Oh, we're gonna get challenged today. All right. I don't know if this is gonna help or hurt. All right, I'm gonna start doing this now that we have more theorems of proving triangles congruent. Now we have 4 instead of 2. And if you want to use this, fine. If not, it's not gonna hurt my feelings at all. Trust me. Because we have a lot of S's and A's going on in the 4 methods, everyone see I had PSQ and RSQ. What I'm going to start doing is putting an A right next to it. That tells me, hey, I have a pair of angles. It just keeps everything organized for me. All right, so you may start seeing that. If you want to use it, feel free. So what else did I have here? All right, I had a pair of angles. I need 2 other pair of something. So where do you and your group go from here? Hook me up, 11.
I said QS is equal to QS.
The old reflexive, right? All right, so that gives me take a look, pair of sides. So at least right now in my head, I'm thinking, all right, this is either going to be side angle side or one of the angle side. I know it's not side. All right, I know it's not side. And that's reflexive. Should have wrote that down. All right, what's the deal with the bisects and the givens? What's the deal there? That should have helped you out. Ones.
Angle PQS is congruent to angle RQS.
Good. PQS congruent to RQS. What do you got, Eric?
Definition of bisects.
Great job. And that gives me another pair of angles. So now I'm looking at my proof and I'm like, all right, I have 2 angles and a side. I know it's doable. It's either going to be angle or angle side. Now the question is, was that reflexive side in between or not? Is this reflexive side in between or not? Angle or angle side? What do you have? 11?
Angle side.
Good, that side was in between. So triangle PQS congruent to triangle RQS, angle side angle. We all good on that basic one? Because now I'm going to get tricky. All right, I'm going to get a little tricky. DAC congruent to BEC. DAC. Doesn't want to do it, huh? DAC, there we go. Congruent to BEC, this angle right here, got it. DC congruent to BC, and then prove ACD and ECB. All right, this is the first time this is happening to us. The 2 triangles I'm asking you to prove congruent are overlapping each other. And for some of us, me included, it might be tough to see those triangles and figure out what do I have, sides or angles. So now I'm going to suggest, if you want to, if great, if not, that's fine too. I'm going to highlight both in different colors. All right, I'm going to highlight both in different colors so I can actually see, hey, do I have angles, sides? How much more do I need? So ACD, I'm going to highlight. Oh, and I'm only going to do this when they overlap each other, just so I can see them. And ECB, I'm going to highlight. This just makes it easier for me, 1, to see the triangles, and 2, do I have full sides or full angles yet? All right, here's my question to you guys. Help me out. The pair of angles I gave you, were those full angles in both my triangles? Can I count that as an A? And side, angle, etc. Can I count that as a full pair of angles? Angle DAC and angle BEC? Is that a full pair in both? Yes, no, maybe?
Yeah.
Yeah, it is, right? Angle DAC is a full angle in my beige triangle up here. And angle BEC, this one right here, is a full angle in my yellow. So yeah, hey, look, that gave you an A right there. Full pair of angles. How about DC and BC? Are those full sides in both triangles? Yes? All good? Thanks, Miss Wise.
Yep.
Appreciate it.
By the way, I'm doing 2 quizzes, not 1 giant test.
Okay.
Try mine this time.
Well,
Do you want me to share them with you?
no, you can. I was going to do whatever the second half was. It's going to be dominated.
Yeah, that's kind
On
of what
that.
I'm doing. Yeah.
I'm not going to go back to like basic SOHCAHTOA problems and
Right.
PyTag. I'm not going to go back to that.
Alright.
So.
Yep.
All right.
Okay, sorry to interrupt.
Nope, you're good. All good? So what am I trying to tell you guys here? You have 2 out of 3 pairs that you need. You only need 1 more pair, and that's on you. The givens are done. So it's got to be something on your own that you see. All right? Discuss it in your group. Where's that 3rd pair or something? Because I already have a pair of sides and I already have a pair of angles. And the givens are done. I've used them. I've used the givens. So it's got to be something you guys see on your own that you can tell me between the 2 triangles. So take a look at both triangles, discuss it in your group. I'll give you guys about a minute. Where is that 3rd pair that I'm missing?
Okay. Yeah, so angle C is angle C. So that would be angle C.
Okay, what was I missing? What's that one piece of angles or sides I was missing here? 13?
I don't know.
Yes, you do. Yes, you do. Look at both. Right? Look at both. You know it's got here's the thing, ready? Okay, say we're stuck like Kevin is right now. You have a pair of angles and a pair of sides. Right, Kevin? So it's either most likely it's probably going to be another pair of angles to do angle side angle or angle angle side. All right? And here's maybe why you're thinking you see it maybe, but you don't think you can do it or not. Remember when we have a shared side? Right? We had a shared side in this last proof. We can do reflexive. We can also do it for angles. Do both triangles have a full angle in common?
Angle C.
There you go. Angles can be reflexive. Everyone good? Angles can be reflexive, just not sides. So angle C, congruent to angle C, reflexive. That gives me a full pair of angles. So now I just have to determine, is this angle side angle or angle angle side? Also why it's nice to highlight them. So you take one triangle right now. Is the side in between or not? And this might be tough. I might get 50-50 here. 50% say yes, 50% no. Draw it out. Draw it out. Draw one triangle out. Watch how easy this answer becomes when I draw a triangle out. Here's BEC. Watch. BEC. Give me an angle I marked on my diagram in triangle BEC. Give me one angle that's marked. BEC. Give me another angle that I marked. C. Give me a side I marked on BEC. BC. You tell me, is that side in between? Makes this problem a lot easier, doesn't it? Because some of you might have thought, yeah, the side is in between. But look, you draw one triangle out and marked what you marked, becomes very easy, doesn't it? That this is actually angle, angle, side. Draw out one of the triangles and put the markings on. It'll be obvious now, isn't it? Questions from you guys? Oh, you guys think you're done. You're not done, just because the notes say. I'm going to give you an honors level proof here. Back of your packet for me. You guys can copy it down. You got a blank page on the back. I'm going to give you guys however much time you need. All right, you got 20 minutes left in class. I don't know if you'll need it or not, but here you go. There it is. This is a tough one. I want you to grind through it. I don't want you to give up. Grind through this one, you and your group. There it is. Prove to me those two triangles are congruent. Take as long as you need. When you and your group are done, call me over. I'm not doing this one up on the board at the end. When you and your group think you have it, call me over. I'll give it a quick check. This is such a great honors proof. Such a great honors proof. Oh man, this is so honors level. You're gonna have to dig deep from unit 2. Theorem from unit 2 here. I shouldn't even be saying that. Think I'm doing this in my regular geometry class? Absolutely not. Come on. This is why you're in here, for challenges like this. Finish. I would start out talking in your group. Did I give you full sides or full angles, and how many? So you know how many more you got to find. And yes, 3, 4, 5, and 6 are numbered for a reason. Use them. Use them. Here we go. I'll take a peek when you're done. Who's got this? What group's going to get it done? It's not a race, but it's about detail. First look at the givens. Did I give you any full sides or full angles? And then how many more do I need to find using the givens? Come on now, come on. Let's dig deep. Talk it over with each other. You got this. Great proof here to finish it off. Finish the day off. What method is it going to be? Anything is on the table. Unit 2, 3, and this unit.
These two.
Dun dun! Yeah, come on. Show me when you and your group are completely